Yep. Just put them in the racks there. How did he go? It went. I like it when it goes, right? When it went. Huh? Oh, my office. Yeah. Give me 1 second. Our problem solved? Ah. It works? No. Like really? Well, so you guys can keep it even down. But if you don't keep it down, you push the time a little bit, then well, like it goes pressure, but then doesn't shoot up. It just like pops off the stumper. And so is it the lower? The lower. We all like it. Use less water. Here be 40 the time. First. I have another one. Yeah. It's right there. One and a half.
Don't jerk.
Let's try that one last time. Oh, because you're in the grass with them.
Thank you. Yeah, would you guys like to bring in this 40 while we get accurate? Accurate. Ours was like 2 feet. That's when ours was 103 inches. Our tank was 174. Okay. So the 10 and the 80 were. Did that really technically be five? Thank you.
Yeah, I feel that. It's kind of-
Okay. Yep, yep. Get the cylinder. Good.
Only go here for you guys. Bye guys.
Well, for some money,
Oh.
for the rest of the month. Yeah. Yeah. One more. Oh, good. Typically, don't want to. Is there some reaction you have to right out? Okay.
Yeah, there are some.
I wanted to.
I don't think they need. They need the, it's like gas calculation. I don't even think we need the.
Chris, no, mine's not bad.
I'll be to send you the measure.
Monday? Can you help with the homework? Anytime and everything. Yeah, it sounds like every year. If you have a question about it, if I know the answers, I'll fix it back. If I don't know the answers, I'll fix it back. On Monday? The what? Monday. What? Privilege. Yeah. Like, I have a lot of friends asking. You know, Like, part of the homework. Yeah, I've been circling all of the stuff because I'm just like, I don't know what happened. 'Cause I didn't remember that. You take the negative out and you take it back to it. Okay.
Yeah, everyone just left.
Oh, there's a, I don't know where the cap. No cap.
Thank you, remember? 180?
30, 33 and 5. 33 managers. 33 managers. Oh, you're just looking at 80. 80. I feel like we had.
It's true. Yeah. Yeah, but this is pretty. That's fine, it's back to 33. You think I admit? We were really surprised that it's back at 90. Because the 80s were 36.
The 40 was kind of air a lot longer.
Yeah. Oh my God. Oh, yeah, yeah. Also, not because they're good chat. Fucking pros.
All right, time to go by dry ice now.
What?
Sorry about that. Are you guys there?
Yes, I'm here.
Are you ready?
Yes.
Okay. Oh, really? What type of computer? It's a Dell. It might fit our HPs, so we'll go back there and see if we can get it to fit. Second. How did it go, guys? It's stuck there? Okay.
Oh, sorry. Sorry for the loud laughing.
That's all right.
He's like, "Oh,
And he just,
yeah."
okay.
Really good with them.
Can you guys hear me? I have some other students online or office hours. No, that's okay.
Oh. This one's good.
So I need to take the 10, I need to take the 10 one off. So you guys had a lot of fails, it looks like, a couple of times. So it's good that we had enough. Oh, that was a good one. That was a really good one. Oh, yeah. Yeah, that was good. Are you guys there? Can you hear me?
I can hear you.
Yeah, I can hear you.
Okay. You have questions?
Yes, with one of the a math problem, and then also a question about the Mentos graphing that we're doing.
Okay.
First I'll go with the Mentos thing. So I ended up doing the link and I ended up copying the raw material.
Okay.
And then
I'll see you guys.
and then I ended up doing, let me just briefly get it. Oh, where did I put that paper?
There should have been 3, yeah. They want to get packed. That happens sometimes.
When I have everything scattered everywhere. So anyways, I ended up doing the whole sheets where it says raw material, the temp, the time, the temp and all that stuff.
Okay.
So my question is, because that's all from the first video that you uploaded.
Yeah.
So then the second one goes in, I haven't watched the second video because I was going step by step. Is that what we're supposed to do from watching your video? Like follow
Yeah.
you and do everything?
Yep.
Okay, so when I did that, are we supposed to, so every time I opened a new sheet was from like the raw one and then it goes, I don't know exactly in order, but I think one was,
Height, pH, temperature.
okay, yeah. So from all those, are you going to want all the data, like the numbers too, or just the little graph?
The graph. The graph is what you're going to be putting in there. If you watch the second video, it'll show you how to put the video, how to put your data into the, your Google Sheets.
Okay,
Or
so
into
mine was a little off from yours. Like you, on the last number, you had 4, I had 5. But I think that's because your chart is a little different because I think you uploaded it when people didn't put all the information in, huh?
Yeah. Yep.
Okay, and then the few things that I noticed was the liter wasn't 1.2 1.25, it was 1.5 for the sparkling water, but you put 1.25.
It depends on your sparkling water, because I had two different types.
Oh,
Depending
okay,
on the
so
day.
mine was, okay, so mine was a 1.5, okay, okay,
Yeah.
so that's okay. Okay, so then I'm good with that, but I do have one question. So when I was how do you save it? So I was freaking out again today and I was like, okay, where did it go? All that hard work today. It took me
It
forever.
auto saves. So as soon as you go back into Google Docs, as long as you have an account, it'll auto save that file. And you do have the same file name and everything like that. So if you go here, let me show you.
So, okay, yeah, because I say the only way I could reopen it is through my history. Other than that, I can
So
find the old one that like when it got halfway deleted when I was doing it, but I can't find my new one only through history. So I could still see my new one through history, but I'm trying to figure out how to save it so that way I do not want to start it all over because it took me forever to do it.
okay, so what you're gonna do is if you go to Google and you're logged in, you want to log in first. See, I'm
Okay.
already logged in. Oh, let me share my screen. You guys can't see what I'm doing. Okay, can you see it now? Yes? You guys
Yeah,
can,
I can
yeah, you
see.
guys can see me? Okay, so up here, it'll say Google Apps. You see the dots there?
Okay, yeah, I see that.
So you click on it, then you're gonna scroll down to Google Sheets. And then, so this will, once it finally opens, it'll show you all of your, okay, so
Yeah,
here's all of my files.
I
Yep.
do see my old one, but not my new one. The only way I could see my new, okay, so like what you just did right now,
Yep.
I can see my old one that where I only had raw material and the next thing, but on my new one, I finished every single thing. And I'm like, the only way I could find it is through my history on my laptop, but not,
Okay, so did you download it or did you, because you have the ability to download it as well.
I don't know.
So if you see up here, can you see my screen right now?
Yeah, and I kept pushing that, but that's
Yeah.
only saving through my history on my phone, my computer, but not through. I don't see unless I don't know where to find it.
It should show up down there. Again, if you go to, is it? If you go to your apps, you go Google Sheets, it'll show up there. It'll show you all of the ones that you've opened recently, right? And if you scroll down, they should have all of the ones that are there.
So if my new one isn't on there, only on history, how do I get it to go on there?
If it's not on there, that means that it hasn't been saved. And so you're gonna have to try to save it from your history.
How do I save it from my history? Do you know?
So all you do is just, what I would do if it were me, let me open.
Because I have a MacBook Air. So
Even with the MacBook, it should actually exactly the same because it's an online file. So it's not gonna be any different. Do you understand?
yeah.
So it shouldn't make a difference whether it's a MacBook Air or anything else. Are you using Chrome?
Yes. Yes. I am. Everything I do is Chrome.
Okay, good. Okay, so let's see. So what I would say is go up here
Mm-hmm.
and just save it as and give it a new name, the one that you have in your history.
Uh-huh.
And say make a copy, give it a new name, and then save it as whatever you want to rename it.
And then where will it be at after that?
It should go into your Google folders. It'll go into your Google Drive. So if you go into Google Sheets, it should show up there.
Okay.
And so let me go back to.
Because I do not want it. I mean, I don't know if it's just me. Maybe I take my time to do things, but it took me forever.
Yeah.
Just
It takes a while.
Just because,
Yeah.
I mean, I got the point, like after, like when I was on the second sheet, I was like, oh, you're just repeating, like you go back, copy group and you locate, or I forget the two things, A and B, then you paste it, and then you got to get like the temp from the raw, like all the temp, all the other ones, then I was getting the hang of it after that, but
Yeah.
it
So
does.
right now you need to go, you can also go to Google Drive, and Google Drive should have everything that you've done from, all of the different areas.
Okay. So I'll just look for everything. So I just don't want to do it over. Okay, so then what I'm doing is correct. That's what you're supposed to do. Watch the video and
Yep.
go step by step.
That's right.
Okay, I just wanted to make sure I wasn't just doing it for.
Okay.
Okay, I didn't want to waste any time with, I could be doing other things for the class, but okay, as long as I'm supposed to do it, then I'm good.
Okay. And let me ask Maya, do you have a question?
Yeah, I do. It's actually, I have 2 questions about the homework from module
Okay.
2.
And then just after that, I just have just 2 problems on the math homework, and then that's it. I'm just stuck on 2.
Okay, so you both have problems on the homeworks. Is that correct?
Mhm.
Yes.
Okay. Okay, Maya, do you want to share your screen so we can see the problem?
Yes, I can.
Okay.
Mm. Okay. Are you guys able to see it?
Ah, this looks very familiar.
Yes.
That's the one I'm stuck on.
Yeah.
Okay.
71
one
and
and
72. Oh
73.
my God, I'm not alone.
Okay, Maya, can you do me a favor and can you see if you can scroll over a little bit so I can see the very beginning or you're starting?
Yes, I can. Oh shoot. Oh. Oh no.
And do you guys mind if I share it? Because I think I may have a student that's also here that needs to,
Mhm.
yeah, let me get this started.
Oh no.
Hey, how are you?
I don't know why I'm not able to scroll over.
They're fixing it right now. Are those mine?
Yeah. How do I do it?
Okay, thank you.
That's weird.
Okay, okay. Okay, okay. And what? String? Okay, I may be able to help you with most of those. Give me 1 second.
Oh no.
What do you mean? Yeah, sure. Take what you need. Okay. Give me 1 second. 70. Yes, can you do me a favor and get the glucose? Glucose would be in the chemical room, in the very back room, and the far cabinet would be on the top shelf. It'll say glucose or dextrose, yeah. And then also fructose, same thing. It should be also labeled. Yep. Just in case. One of the homework moments. I said just in case. One of the homework problems.
No.
How about now? Can you hear me? Hello?
Yeah, it's a little echoey though.
Okay.
Okay, it's okay.
Okay. Okay, so let's go ahead and start with that problem. I'm gonna see if. Okay, so your starting point, right? So when you're starting, you never want to start with the ones that have like GTE over milliliters. That's not going to be your true starting point. So in this, your true starting point is going to be that 600.0 milliliters. Okay, that's what you want to start from. Okay, and so we're starting with milliliters, and then it says the drop factor. So the drop factor for the tubing is 12.0 GT per ml, right? So then that gives us what we need to know about the ml. So that's how we can get rid of our mls. So if you drag that to your second spot,
This
So it would be 12.0 GTT on top.
that's right.
one. Okay, got it.
Because anytime you see /mls, it's understood to say 1 ml. Okay.
Okay.
Time you see that. So that's the first thing that you should think. So that means that there's a 1 exactly.
And what does GTT stand for?
It's just a drop rate. It's just I don't know what it exactly stands for. It's like gravitational something else, but I can't remember.
Yeah.
I'll have to look it up. I'll look it up for you because I can't remember what it says. Okay. So then in this case, now we're left with the units of GTT. But we're trying to get to what is our goal? It says, so the drop factor. So what is the correct flow rate settling in drops per minute? What was that?
I think it's like gravitational transfusion.
Yeah.
So I put 1 drop on top and 1 GT on bottom. On the second parenthesis.
Oh, yes. So you're gonna put the next set of,
Yes.
like you said put 1. Yes. So
1
it-
drop.
you can just drop per minute. Yes. There we go.
Okay.
So we know that.
Oh, no, not the minute. I put GTT on bottom. So they can cross out from one side to the other.
I
Oh,
see.
yeah. Drops per.
Yes.
Got it.
So drops per. Yeah. Okay. So your GT.
Yeah.
We know that it's a 1-to-1 ratio, right?
Yeah.
Okay.
Okay. So the next thing that we also know is that we want.
The 8 hours.
Yes, we want the 8 hours, right? And so this is the kind of like that tricky, because right now it's drops. We have drops, right? And we're left with just drops. So now we have drops over this full time, right?
Mhm.
So we need to find a way of getting our,
This is where I get stuck. So I put 8 hours on the bottom, but then I'm just stuck what to put on top.
yeah, I see. This is a part that's a little bit tricky, right?
Very tricky.
The one thing that we could have done is at the very beginning, right? Because we started off with milliliters, right? But it's basically milliliters per 8 hours, right? So if I could use my starting point, go back to my starting amount.
See, that's what I was thinking too. I go, maybe I have to flip everything and start out in a different way. Don't
Yeah.
start. Okay, so then it wasn't okay. Then I
No,
was.
so you weren't too off. So let's go ahead at our starting amount. Let's go ahead and drag in, put
Okay.
where it says ml per hour.
So we're gonna.
Drag your ml per hour at your starting. Oh, you didn't have to start all over. You could left.
Oh, no.
That's right. Yeah, no, but don't put ml. Just go
Okay.
ml hours. So drag it down here from the bottom.
Oh,
Put it like on the bottom, right? The bottom. No.
There we go.
okay.
That it's not doing it the way it's supposed to, because I wanted to put both of them on.
In the other bracket, right? Or am I confused?
Yeah, no, you're not confused, but what I'm trying to get it to do is it's not behaving the way it's supposed to. I wanted to split it up because you're doing a patient, one patient is getting 600 mils of IV over 8 hours. So that's 600 divided by 8.
Let me get my calculator.
Me too.
600 divided by 8.
Mhm.
Okay.
0.016.
No, it shouldn't be that much.
75.
Wait, did I do it wrong? Let me see. You said 6.
600 divided by 8.
Oh yeah, 75. I did multiplied, sorry.
Oh, but the problem is that we don't have that 75 down here, right? So Give me a second to think. Okay, so let's go ahead and work our way through it the way that you're doing. You're doing right. Go ahead and finish the rest of it the way that you had it before. And then we'll get back on.
Times. It was drops per minute, right?
Mhm.
Drops per, okay.
It's not drops per minute.
Or drop per
Drops per,
G.
yeah,
Got it.
Yeah.
want to get rid of that. And remember, it's 1-to-1.
1-to-1 ratio. Got it.
And then where does the 8-hour come in?
Yeah, so technically, we need to be able to put that 8 hour under the 600, but it's not letting us do that.
Mhm.
So that's,
Yeah.
yeah, that's where I'm getting stuck at, so. Let's see.
Yeah, because I tried everything. I was just like, there's no way you can't define the 8 hours into anything. Because I was like, wait, I tried and I was just like, I can't.
Yeah,
Mm.
okay, so now go ahead and drag the rest of it, because now you're gonna change your, because in theory you have hours, you want to change that to minutes.
Got it. So drops per minute, right?
But it's 400 and something minutes per. Okay, looked at it and the number wasn't there either.
Hmm. I don't know.
One second. How long? Did she say how long?
No, you guys?
Okay, so you want to do the conversion for hours to minutes. So if we want to get rid of hours on the bottom, we want minutes on the bottom. So then,
Hours over minutes? Okay. Oh, got it. And then-
that's fine. So that's fine. Okay. Yeah, so we should have, what is the correct flow rate? Yeah, let's get 8 in there somehow. It's not working out.
So we have two then even that other problem, I can't remember. I don't remember. It's 26.
62, huh?
Yeah, but this is normally how you would set it up. The only thing, in this case, you'd end up with dividing with the 8 at the very end. And for some reason, it is not. Hours. Seconds. Let me look at something.
Maybe the starting number has to be different. So that way we can get the 600 somewhere else.
I'm pretty, no, you usually start off with that. I'm like 99.9% sure. But let me take a cheat mode and take a look at it.
Let me know where you're looking at. Just kidding. Oh my gosh. I just have one more problem and I'll be done.
Me too.
Is it 71 and 72 you needed help with?
I have 71 and 73.
Oh, I
You
just
have 73? I have 72.
Yeah, I just need 71 and 72 and I'm done. I'm like, hallelujah. I'm
So
done.
which problem was this again?
71. That's problem 71.
This is 71.
Mhm.
Okay.
Yes.
Well, you gave us a fair amount of time to get our homework done, so that I can say it's just
I
like,
agree.
yeah, you gave us a really, it was really good amount of time for the homework.
That's good. I'm glad.
I mean, because I just started it once I seen it. Like,
Me too.
so it
We
worked
just
for
kept
me.
going.
Yeah, I just did a little here and there.
Hmm. I think maybe in between the last two conversions, we multiply 600 mil over 8 hours, and then
Well, when I
it
did
would
my,
cancel out 1 hour, right?
I don't know, when I did the first time I ended up,
See.
when I first did the problem, I did it a little bit different than the way you had yours set up. So
Yeah.
whenever time I submitted it, it always said my fourth equation was wrong. That's because I couldn't change the hour to anything. I tried like
Okay.
putting everything in there and it just wouldn't work.
No, that wouldn't work. Hmm. No.
How many tries do you have left?
I think at least like 16. I only did a few. I did like probably 5 or 6 tries.
Yeah, that one got me stuck. Have you started your Mentos thingy?
I have not. No, I just completed the one where we had to do it on the sheets and put in our information.
Oh, the one
Or
where
our
everybody,
stat.
like your group had like
Mhm.
one person out of everybody had to write it down.
Yeah.
But you didn't send in any questions yet, right? Aren't you going to save that for your 300 That's what I was going to ask them.
What do you mean?
What are you asking me?
Okay,
Mhm.
so one of the when you go to your grades and it says assignment was due and you had to upload something, but we weren't supposed to answer those questions and upload it, right?
No, you're answering the questions in your lab report.
Okay, good. Okay, so then I got it. So it's gonna be official. Okay, so I'm good
Yeah, all I
then.
have to do, since all the groups put their data, even though some people put their data twice, or, I'll give, everybody gets credit for it.
Got it.
It was just getting you guys to have all your data up there. That was
Okay, and that's not due till next week, huh?
your lab report isn't due till this Sunday. Yes, it's coming Sunday.
Okay,
Okay.
that's enough time. I got it.
Yeah, this is a bit of a mess here.
Can you see the answer?
Mhm.
Yeah, yeah, the answer's 15, but
I got
it's,
Oh.
yeah, but it's the drag and drop. It's not letting you do the last part, the last thing that you need to do, so. that's
Thank
the
you.
problem.
I think I'll work.
Okay. Good. Okay, give me one second.
The other side.
Are we gonna go over more of the chapter 2 and 3 still, instead of going to another chapter?
Yeah, we're gonna finish. We haven't even really gone over chapter 2. We'll be doing that today, and then we'll finish up chapter 3 today.
Okay.
Okay, good, because I was like, that was another thing, because I'm not overwhelmed with the homework and or the other assignment we have. It was just more like I wanted to go keep reading what we were going through already, because that's where I was getting like kind of like I feel like I put so much effort in the homework, but not too much into like writing the vocabulary words that you put out there. I really wanted to look them up and
Oh, yeah.
start studying them.
Yeah, so the answer is 15. But
But it won't let us,
they won't let us get to that last part, so let's see. That's what I'm trying to see if there's a way to.
maybe you can just do it. It's one of those problems.
Yeah, I don't know.
Yeah, because the way it's working out, your drag and drop isn't gonna get where you need to be, right? Because we need to get over, you have to have 8 on the bottom.
Yeah, because you want it to, like, it's just the 8 hours. I don't know how to make that any different. You can't use 600 again?
Yeah, that's what I thought. Like multiply the 600 milliliters over 8 hours. But I don't know.
Oh,
This is the benefit of
yeah, that's why I tried.
Give me 1 second. Okay, I'm gonna share mine with you. Yeah, it doesn't work the way it should, but let me show you how they do it.
Oh, yeah.
Okay, do you guys see? It's the same thing that you guys did, only thing I put 8 over hours here, I just put a 1 there to let it on top. So you guys, your answer was right. Only thing is that we need to be able to divide it by the 8 hours. And the only way to let you do that is by doing it this way.
Okay.
Give me 1 second, and I'll be right back.
So
You want to? I'm sitting here until. With the camera on.
we-
Really? Oh my gosh, that seems so complicated.
oh no. Why would it do that to me?
Honestly, I'm starting to think that Mr. Cobra wasn't the problem. I'm starting to think it's third high school, that man. I'm starting to think like, he's an awful teacher. I kind of miss him. I kind of miss him. I miss him too. Yesterday, you ever have Mr. Sly? Yeah. Yesterday, my biology professor said potential. Remember how you say potential?
Oh, no, you're good.
Almost done.
How did you do 72?
I can show it real quick. Let's see.
I'm already like,
Dr. Henry, is it okay if I share my screen again?
He's my
Is he in here?
oh my,
Oh,
God. Or maybe just,
okay. You have what's it called? Oh, it's okay.
We don't have classes, but
Oh, we don't?
yeah, but you're informed this
Yeah.
following Tuesday.
So 2 weeks.
2 weeks.
You have 73, right, Dial? Or which one? Yeah,
I have
73.
73. I need help with 72.
Like
Oh, really?
Okay. You have 73 though?
basically choose the hobby, but it's one of your hobbies. And just
Okay.
go back
I
and forth.
need help with 73. But for 72, I started with 150 pounds per patient.
That we're doing.
Your starting amount was,
Yes, you
The 150.
13 or
Okay, that one. Or
I got, oh yeah, oh, then I put it wrong. I had put,
the one
1250. I don't know why I put 1250.
Okay.
and it's again.
And then I put, okay, so a patient is required to take an IV drug for cancer treatment. The required dosage is 5.0.
Like,
drug per patient. So 150
decided to get this one.
patient is the starting amount.
Mhm. And then I multiplied it by the 5 mg drug over 1 pound, over 1 pound patient. This is the first conversion that it shows.
Well, that's the whole point of it. So you get, get it on.
The one mg drug bag. It's just the 1 mg drug, right? No.
Well, it's 5 mg drug on the top and then 1 pound patient.
Oh yeah, because it cancels it out from the pound to the
Mhm.
pound.
Yes. And then the next conversion will be 1 bag over the 250 mg drug.
Yeah, no, and then,
The 1 pound bag or the one?
Or sorry, just 1 bag, sorry.
or what is it called?
Okay, then after we'll just you'll can help me explain it because I really want to, you know what I mean? I need to like,
Mhm.
these are so hard. I mean, they are.
They
but-
are.
I mean, you got to take the time. That's what it's like. I just
Yeah.
I
You
can't.
just have to know the conversions as well, or what each thing converts to.
And to cancel out underneath the bag, I have to have MG drug on the bottom, right?
Yes.
So we use the off.
And was it 1 again?
250.
We also had this one.
That's because each bag contains 250, like
Yeah,
per
okay.
1 bag. Yeah.
Okay.
Yeah, so just look up.
And then now, so I see we use the MG drug. So I'm reading the whole paragraph. So we cancel the MG, the pound patient. We can't use that again. So is that it? Because we use basically everything, and then now it's just going across with the answer, right?
Yes.
So
Which is
let me see if I can get it on the calculator. Let's see. 150. 5.2. 250 equals. Did you get 3.0?
Yeah, really?
yes.
60.
Hey, I did it right. Of bags. Let's see if this works. Oh, I hope I did it. Let's see. Let's see. Oh my gosh. That was not nearly as hard as the other one. Oh my.
No.
Okay. Want help with
Can you
it
go over 73? Yeah.
first? Okay, so 73, what is the mass in grams of 2.50 gallons of water? The density, what did you, okay, did you already start it so I can see where you went wrong?
Yeah, so for the starting amount, I started with 2.5 gallons of water, or just 2.5 gal.
Yeah, I put 2.5 gallon and then,
And then the first conversion I had did
3.785 liters,
yes, milliliters, right? Or is it liters?
just liter,
Oh, just liters?
mhm,
Okay, I had did milliliters.
which is 1 gallon.
Okay, per 1 gallon. Got it.
And then in the next conversion, how many? So you count, so from the starting amount gallon, so you cross that out because then on the conversion you just did, as you can
Mhm.
see, gallon towards gallon got crossed out. So now that you have that 3.785 on top with the liters, you want to go diagonally across to get another liter.
Okay,
Mhm.
It'll
you guys
be,
are helping each other. We're having some technical difficulties.
oh yeah, we're doing good
Go
right
wrong, it's gone wrong,
Yeah,
so-
we're good.
now.
Okay,
Okay.
yes.
So 1 liter on the bottom, and then how many, what makes a liter, like 1,000 milliliters, obviously.
Yes, 1,000 milliliters, right?
On top.
On the top.
So
Got
now
it.
you want to go on your next conversion, which you're gonna have another one. You want to cancel those milliliters that you just did. So you have that 1,000 milliliters already on top on your old conversion. So,
On the top or on the bottom, right? Or
Okay.
for the next one?
okay, for the second conversion, you put 1,000 milliliters on top and 1 liter on bottom, right?
Yes.
Okay, so now you're gonna open another conversion.
Okay, got it.
You need to cancel out that milliliter that was on top on that
Mhm.
second conversion.
Got it.
So that means on your third conversion, you're gonna have to have milliliters because you need to cancel it out. So it would be 1 milliliter on bottom, which is 1 gram.
Oh, okay, got it.
And then on
And
top,
that is to,
so then equals your answer, which you have to do the whole thing across, which is,
let's see. And then it'll be in the scientific notation, right?
Mhm.
Okay, so let's see.
Oh.
Oh, yes. Okay, I got it.
grams. So it'd be 9.46.
9.46 times 10 to the third grams, right?
Mhm.
Okay, cool. Thank you.
Did you put it in already?
Yeah.
Oh, okay.
Okay,
So
cool.
you're
We
done
got
with
it, Mom.
I know, we're done.
Yes.
Hallelujah.
Such a relief.
Oh my God, the only one that nobody got is gonna get is 62, but I think he's gonna give us everybody credit for it.
Mhm. Okay, cool.
So I think I'm gonna submit mine.
Okay, did you guys get all the homework done since I was gone?
Yeah, we just both,
Yes,
we
we
were,
did.
it's funny because we were both stuck on the one of the problems and then she was stuck on 72 and I was stuck on 70. No, 3 and I was on 72.
Mhm.
So we helped each other.
That's good. That's
But I
what-
do get how counseling
were-
across makes more sense.
Yes.
Okay, so do we do lecture now?
Yes, we're gonna be doing lecture now, but there's like a few more people that had a couple of questions before that. Just
Cool.
Oh, okay, so we can submit this and we're done, right?
helping me with. we were gonna have to-
Okay, we should just,
Oh, yeah. I'll have to catch up with it on that. With
all
it,
right.
getting
Do we
them-
just log out now?
Okay.
Okay.
Do
Do we log out now?
you guys can log out if you choose to log out. We're gonna have lecture here in a few minutes. But I have a couple of handouts and then for my Kalinga class, you guys, I need to upload. I have the instructions on how to do your lab reports and how to finish working with your data. And so it's a video and everything like that. So I'll email you guys that when I know it. I'll put it on your Canvas shell. It'll be up tonight so you guys can work through it. Okay, and then so I'll give you guys till next Wednesday to get the lab report done. So then that way you'll have a full week to kind of work.
Okay. So this is where we stay in for lecture though, so I could just stay in then, right?
You can stay in this one. It's the same link. Yes.
Okay.
Okay, so let me hand out some more papers. A couple more trees. I did this time. I remember. Well, were you upset because I did a whole bunch of last ones? I was so efficient, I made 2 copies. Okay, so last we left off, were you able to log in, Jerry? All right. How's the homework going, by the way? It's going. Yes.
Mia, I have a question.
Yeah, what's your question?
I was gonna ask you, so you know how we did the assignment, there's no submit button, right? It just says late submission is allowed, or is it?
No, it just automatically submits, like it gets graded on Canvas already.
So like if
I'm
you don't,
pretty sure.
like just say we never touched it, then whatever you finish, it just submits like that?
Yes.
Oh, okay, because I was just like, I was like trying to find that, I don't
The
think,
submit button.
yeah, I've never done I mean, I've done assignments, but not like in this class where it's doesn't have an actual, like you're done type of thing.
Mhm.
So you were able to do 62, the one that nobody could get?
I think so. Yeah, I think I did do it.
I'm gonna try to
I
do
don't
that.
remember how though.
Yeah, no, I'm gonna try to do it tonight. It shouldn't be that hard then. One of the other girls said she got it too, and I remember she's in the group next to mine. She said she did it.
Oh, actually. She's flipping.
No. Okay. How's everybody's week going? That good, huh? You guys like being in the dark? Yeah. So we have to finish up chapter 3, then finish up chapter 2. It's gonna be fun. But a lot of chapter 3 we've already gone over. We just haven't realized. Okay. So sig figs. Significant figures. So significant figures have to deal with inaccuracy, right? Or uncertain. So how many of you guys have weighed yourselves? On a scale, weight. Okay, so I'm actually going to go to the board here. Okay, so you weigh yourself on a scale. And you use this analogy once before. So make sure if you guys got it the first time, you get it back or resubmit. So the first weigh, let's say I'm weighing me. So I first weigh myself. I weigh 220. Okay. And you know, you can't just weigh yourself once. You're like, yeah, that can't be right, right? It's like I was at 223 last month, right? So let me get on the scale again. Now it says 225. Then I get on the scale like 225. No, it's going the wrong way. I need to weigh myself one more time, you know, just to be sure. Okay, 221. Okay, it's going in the right direction, but that still can't be right, right? So I'm gonna weigh myself one more time, just to be sure, right? 224. Okay, so at this point, I weighed myself 4 times. Did I get the same reading for any of those 4 times? Am I confident about those readings? Right? Because last month I wasn't that much weight, right? This month I'm like this. I'm like, huh? So if I look at it, and I take a look at it, are there numbers that I'm certain about? That I'm sure about? Okay, which numbers in my weight am I sure about? Am I sure about the hundreds place, tens place, or the ones place? The hundreds and the tens. So these 2 spots I'm sure about, right? So this last spot is fluctuating. It's unsure, right? It's uncertain. For sure.
left you? Did you call him and say, where you at, girl? That's what you're supposed to do. Anytime your partners don't show up, where you at, right? Did you get a phone call?
I did.
You did?
I did.
Oh, so you need to get on your crew, right?
Yeah.
And speaking of that, where's your crew? She's missing MIA. Okay, so anyway, I'm uncertain about this last spot. So because this is uncertain, we're not sure about it, right? We're gonna take a look at those numbers, and then we know that this is unsure, right? So if I was going with significant figures, I would want to show this of having only two significant figures because this part is uncertain. Okay, so I would enter a number as 220, right? I like it a lot because it's 220, it's less than 225 and much less than 230, right? Okay, because of that uncertainty. Okay, now when we're talking about significant figures, we're dealing with that uncertainty. We're trying to account for that uncertainty. So by us putting a 0 here, we're saying we're not sure about that 0, right? It could be 1, it could be 2, it could be 3, it could be 4, it could even be 5. But I know it's less than 5. Okay, that's the best I can do. Right? And so by doing this, you're trying to account for any errors that could be made with that uncertainty. Does that make sense? Pretty clear? Okay, good. And I know we talked about it, it's just that reminder. Okay. You guys at Harnell, is that clear? You guys can close that back door unless you like it.
Yes, that's fine.
Okay, now when we talk about sig figs aren't going to apply to exact numbers because exact numbers are kind of like, say, I'm 100% sure these numbers are perfect, so I could put a 0, 0, 0, 0, 0, 0, 0, 0, 0 after that number. And usually exact numbers are given to you in like measurements, like you say, I have 5 cups, and you just say 5, that's it, and cups. So then it's going to be understood to be cups. You're looking for it's chapter 3. Then we get to chapter 2. Don't worry about it. We'll get there, I promise. Okay, so we have what we call leading zeros. So these leading zeros here are not going to be significant. So we only have 2 sig figs under these circumstances. I got to remember they can't see me pointing to the screen. So these zeros here are not going to be significant. Non-zero numbers are always going to be significant, right? So in this case, we have 2 significant figures. These zeros are just what we call placeholders. They let us know that that value in this case is pretty low. It's a very, very small value. These numbers here, again, are going to be significant. So we have 3 significant figures here. These zeros are not. They're just placeholders. Okay. Now lagging zeros, if there's no decimal there, then these lagging zeros are not going to be significant either. Only those non-digit numbers, those non-zero numbers, or numbers that are going to be found between 2 non-zero numbers. So in this case, these 4 are going to be significant, where the zeros are not going to be significant. In the case of this number here, we have 5 significant figures. The zeros are not going to be significant. Okay. In the case of what we call captured zeros, zeros that are between 2 non-zero numbers, then in that case, all 3 of those numbers are going to be significant that I have searched. That 0 is now going to become significant. This one here. those 4 numbers are going to be significant. Okay, so if it's captured between 2 non-zero numbers, it's going to be significant, where all the other zeros aren't going to be significant. If I use a decimal, like I did here, that means that I'm sure about this number. So in this case, we have 5 significant figures. Because I put the decimal there, I'm telling you that the zeros following it are going to be incorrect. In the case of this number, we have 1, 2, 3, 4, 5, 6, 7, 8 significant figures because I put the decimal there. Okay. Questions? Questions? And again, we talked about this. You guys should be pretty okay with it, right? Okay. I'm going to test it out here in a minute. Okay, so let's go to the shared screen. I'm going to put a couple numbers up, and I want you to tell me how many statements I have. Okay, so for the first number, 203,000. How many sig figs? How many significant figures do I have?
3.
Okay, I have 3 significant figures. Okay, what about the next number? Everybody agree? 6.
6.
Okay. What about the next number?
1. Wait, is it just 1,000 or is it 1,000.40?
It's just 1,000. Okay, what about the next 0, which is 470.0000?
7.
7. Okay, and the last number. Okay, piece of cake, not too hard. You guys all seem to get it, right? Okay, so when we're doing addition, that's when we have to do, or subtraction, we're gonna have to line up things. And so we have to determine the one that has the least amount of significance, and that's the one that's gonna basically determine where our sig figs lie. Okay, so you guys remember the drill? So if we have our first number, start over here. Start right here. Okay, so we look at this very first number. Where does significance end? Okay, so tell me the 2 numbers that it ends between. So like in the very first number, is this 2 significant? The very first 2?
Yes.
Okay, what about the 0 here?
Yes.
Okay, what about the 1?
Yes.
And the next 2?
Yes.
Okay, and the 0, is that significant? No. So significance would end right after that 0. So we're going to draw a line here. Really, I haven't been drinking yet. Okay, so the next number. The significant ends after the 2. It ends after the 3. Okay. So line is going to be at the exact same spot. What about the third number?
That's up to 2.
It ends after the 2. And our last number after. Okay, so we have 2 choices, right? And I know you're colorblind, so we won't say a color. So we'll call our choice A here and B. Okay, the first thing we're going to add it up. So we have 0. That's going to be 6. That's going to be 3. Two, and okay, so 32,360. Okay, so we're going to find the one that gives us, in the case, the least amount of significance, right? So we're looking for the line that gives us the least amount of significance. You're always going to choose the line that is the furthest to the left. Okay, so is that going to be A or is that going to be B? It's going to be B. So we're going to choose this line, the B. Okay, so we're going to look to the right of that line, and we're going to look at that number. So that number is a 3. Now, if the number is greater than 5, we round that 2 up. If it's less than 5, we're going to leave that 2 alone and just put zeros after it. Okay, so is 3 greater than 5 or is it less than 5? It's less than 5. So my answer should be it's 32,000. Okay, and we want to make sure to include those zeros, because if we don't include those zeros, then we're going to be keeping ourselves out of money. Get some money from somebody. Doesn't somebody owe me some money? They were supposed to cash at me or Venmo me.
I forget. trust me, I
Okay, okay. See, that's why I thought you didn't
No,
come
I
on
didn't
Monday,
forget.
right? So,
Make sure
like,
you get cash. Make sure you get cash.
okay. Okay, so in this case, how many sig figs do I have? I have 2. Okay, so that would be how I would do addition and subtraction. Okay, so what I'd like you guys to do, you guys do the next one. The next one. Let's do this one. And then you guys walk me through. Okay, go. Everybody get a handout. So how many people finished their homework? Good. How many people have done a third of their homework? Okay. How many people have not even looked at their homework? Hey, that's good. I like seeing that. That is really good. You guys at home, you can raise your hand too. Okay, I'm gonna extend your homework by 2 days. By 2 days, you should have it all done. It's gonna be all or nothing, okay? 2 days, all your homework needs to be done. Okay, so it's gonna be extended by 2 days. And reminder, I will have office hours before this class normally, and then also I have office tomorrow hours at 11 via Zoom. I'll send you guys here. I'll give you guys the Zoom. So you guys have questions.
It's only on the.
On Zoom. On Zoom, and then you've also got emails. Kalina, you guys have got emails from the tutors.
And then how long is this?
What was that?
How long is the Zoom meeting gonna be?
Only an hour, because I have a class.
Okay.
So it's gonna be quick,
Tomorrow,
from 11 to noon.
okay. Can be, there's not gonna be no tutoring tomorrow, right?
What was that?
There's not gonna be any tutoring tomorrow?
I may have one of my tutors working. I need to find out. I haven't listed everybody's schedule. I need to put everybody's schedule on.
Okay.
So I'll be putting that out. I just need to go.
5 to 7 on Friday.
Oh, that's right.
So that kind of works out, because it's, I guess today's Wednesday, so Fridays, if I give you 2 days, it'll be due at 11:59 PM on Fridays. I need to fix your time. That's what I forgot.
9 hours?
No, for your homework. 'Cause your
Oh,
homework
what's
was
it
already
for?
due, yeah, it's already been due, right?
Yeah.
Yeah, I need to fix that, so. Okay, you guys ready? Okay, so the first one. Where does significance start or end? After the what? Okay, what about the next number?
The 2?
After the 2?
I mean, yes. No.
It's also gonna be after the 1. Right? Okay, what about the third number? After the 1. And the fourth number? After the. Okay, so let's go ahead and add it up. 2, 1, 5, 6, 0. Okay, so we have A, B, C. Which line am I going to use?
See,
Okay, I'm going to use C. Okay, so then am I going to look to the left or to the right? To the right. So I'm looking at the 5. Okay, it's 5. So am I going to round up? And leave it alone? Are you sure?
Yeah.
Okay, so I'm going to ask you a question. So if I have 5.12, is that greater than 5?
Yes.
So if I have numbers following here, that means that this guy would be greater than just 5, right? Okay, so am I going to round up? Or am I going to leave it alone? I'm going to round up. Okay, so now I have 1 point. Zero, 1.
even though it's 5, still round up.
Because it's not exactly 5. Is
Wait, why do you have 8?
Oh,
that 8? Did I miss? I'm sorry, 6. Because I can't read my own third grade handwriting.
I'm like, okay, wait.
so the decimals matter. So even like say it's 5.1, that's still greater than 5.
That's right. So then it's 7. Yeah, I even said 6, but I decided to write down. Okay, now subtraction is going to work exactly the same way. So this one is easy, right? So let's go ahead and do it. Get it done. So where am I going to draw my line at? First. After the 2. What about the next?
after this. I guess I should probably start using different numbers then. Okay, so let's go ahead and do that math. Okay, so here's A and B. Number am I going to use to determine whether I'm going to round or leave it? The one. Okay, is 1 greater than 5?
No.
So then my answer should be
8, 0, 0.
8, 0, 0. Okay, one last one for the road. Well, not really for the road yet.
Why did you round up the 1?
I didn't round it up. It's 1, right? So it's 8, 1, 2, 0. So then my answer is going to be 8, 0, 0, 0. But we're using that 1 to decide whether it's greater than 5 or less than 5.
I mean, why did you choose the 1 to decide?
You always choose the number that has, like when you're doing the addition or subtraction, you're always going to choose the one that has the least amount of significance. That's going to kind of dictate what you're choosing, you know, how good your numbers are going to be, right? So if we look at this number here it has less numbers of significance. It only has 2 numbers of significance, where this one had a total of 5, right? So by looking at it and lining them up, where it loses its significance makes a huge difference. So that means that we're not 100% sure about that 1, right?
Got it.
Good question. I always love the subtitles that come out. You know, somehow honey came out of there. Okay. Last problem on this page. Okay. Where am I drawing my line?
3.
After the 3. Oops. Okay, what about the next number? After the 1. Okay, so that's 3. Tell you to check my math. Okay, so where am I going to, what number am I going to use to determine whether I'm rounding or leaving it alone? So we're gonna round up. Okay, so my answer is gonna be
.99.
99.
Yeah, because it's 10 minus 1 is 9.
you guys to check my math. Just checking out, 0.994.
99. Oh, yeah.
Okay. Questions? Concerns? Cash? Wait.
So I was a little confused on the, after the 0.9. Why wouldn't it be 0.900? Like we did with the 8000. Is it because of the decimal?
So if we look here, this red line, right? These numbers, there's numbers that are there, both of those areas, right? Meaning that we have significance there because there's a value that's given us there. After that, we don't have any numbers here. So we know that there's no significance there at this point, right here. Okay, so that means that we're sure about these numbers, but anything that's after that, we don't know anything about. So in that case, it's all the way up until this point, right? So everything else has significance that's on the other side, on the right-hand side. Does that make sense?
Yes, that does.
And is that other one 8100? Because I can't really read it, or the
Oh,
problem.
here. It's 80.
800, because the last number has
Zero.
zero significance.
Oh,
So that's what,
so you just
yeah,
Drop.
that's what threw me off on this other one, that there was, the last numbers were significant 1. So you
Yes.
add those.
so on 80, it's 3 zeros, right?
Yes, 3 zeros. Again, my third grade handwriting.
So I see that you have 8 and 3 zeros, and the other one you just dropped the other number, right?
Yeah, because here, this, if we just use 8, is 8 and 8,000 the same? Let's say I owe you $8,000 and I just pay you $8. Would that be okay with you?
No.
No,
They're not the same. So you need those placeholders to remind me that I owe you $8,000, not just 8. Does that make sense?
Yeah. Mhm.
So we're not changing the value or, the range of it. We're just trying to tell you that we have significance. So 8 and 8,000 are not the same number. So we are always going to need those placeholders, right? To let us know that that's the value that we're talking about. Or ballpark value.
But on that other one, 994, there, you don't want to put that 0 there where the
No,
3.
because then you're telling me if I put that 0 there, you're saying that you're sure about that 0.
Oh, okay.
And we're not sure if that's a 0. Right? So if we put that extra 0, you're telling me more information than I need. Does that make sense? And then is it going to really change the value that you have if it's 0.9940?
Actually, no, yeah, because there's a decimal. Yeah, it wouldn't even change it because it's a 0.
Okay.
So yeah, now I get it.
Okay. Okay. Ready to move forward?
Mhm.
Ready for a beer?
Yeah.
yes.
Please. Okay, so next thing is multiplication and division. Okay, so now when we're working with multiplication and division, in this case, we're going to be using the number that has the least number of significant figures. Okay, so let's start off with the very first one over here. So that very first number, underline, how many significant figures do I have there? So it has 1 significant figure. And then this number here, how many significant figures do I have here? Are you sure?
4?
Are you sure?
3.
Okay, there.
Oh, 3. 'Cause you don't count the last zero.
Yeah.
Last zero is not significant. That's
It's
right.
not significant.
Okay, so which one is lower? 1 or 3? 1. So my answer is going to have the one that has the least significant figures, which is 1. So my answer should only have one significant figure. Okay, so what is my answer? What's that? Did you say 2? It is 2. So if we did the math, the answer normally would be 2.020, right? And then we know that we only have one significant figure. So we look here. Is that number greater than 5?
No.
No, it isn't. So then my answer is just going to be 2. Okay. So the next,
Okay, so you didn't multiply anything. You just chose between 1 and 3, which ones has the higher number, and then did the significant
No.
figure.
I
do
did
that.
multiply, right? So if I multiply this number, yeah, I'll get 2.02, right? That will be the answer normally, right?
Oh, okay, so you multiplied 0.001 times 202.
Yes. And so when I get that, I get 2.020, right? So then I look at that 0, I mean, at the number.
Oh, yeah.
So
Okay.
I only want one significant figure. So I look at this number, and since that's a 0, I'm not gonna affect my 2, right? It's not gonna get rounded up. Okay, so then my answer is just 2, so I would have one significant figure. Okay.
Perfect.
Okay, what about the next question? The next division. Division is going to be exactly the same thing as multiplication, right? So we want to find the one that has the least number of significant figures, and that's our answer is going to have the same number of significant figures as the one with the least. Okay. So how many sig figs do I have for this number?
4.
I have 4. And then what about 3?
2. Oh, 3 because of the decimal,
That's
or
right.
is it 2?
No, it's 3 because of the decimal.
It's made like that. It's supposed to be there.
Yes, because exactly, we have the decimal and we have that 0. That's telling me that I'm sure about that 0.
You're sure about that 0? Okay.
Okay, so then my answer is going to have 3 significant figures, right? Okay, so if we go ahead and do that division. Sure, you said 233.
3, 2.
Oh,
My budget. Dos pesos.
okay. Are you sure?
Yes,
Put money on it.
yes.
Okay, on 500? Oh, she's a gambler. I probably, yeah. I only have a
I have
dollar left.
Monopoly.
Not Monopoly money. I want real money. This ain't Monopoly. This is the real world, right? Do you guys agree with that answer? Yes or no? Those who agree, raise your hand if you're online. Those who disagree, or put your thumbs up or whatever it is. Okay, those who disagree, raise your hand. I mean, we'll say put your thumbs down like this.
Somebody has to do this. So, I go with it.
You're going with the dirty work?
Yeah.
You gotta vote, okay? You can't say neutral. Either you're with her or you're against her, okay? It's real simple. Everybody votes. If you don't vote, take your points out. Okay.
But it's only asking for 3 significant. Pero los ceros son
That's right.
antes. Well, then it's gonna be 331.
That's right.
What? It would be 3200. See, I made it work.
Gotta make him think about it, right?
Yes.
You sure you didn't want to bet that $500, right?
Monopoly,
Okay,
yes.
so are you guys still sure this is correct?
Well, that's not 3 significant numbers then.
Is it three? It is 3 significant figures,
Oh, that is.
right? So we do have 3 significant figures, but is it correct?
I think.
Does it need a decimal?
How many people, so now we have this new number. Now I want you guys, how many people think that the answer that we have on the board is correct? Put your thumbs up if you think it's correct. If you guys think it's incorrect, thumbs down. Everybody votes. Thumbs up, thumbs down. Everybody votes. And that means you too, you guys at Harnell, you guys have to do the same thing, or people who are online. Thumbs up, you know. Okay, you guys have your vote? So let's discuss it. So what is that rule about 5?
It goes up, no,
Always?
no, because you have to have the, so, no. less than-
Yes, you were, if it's 5, you round up.
No, I didn't say if it's 5, you're out.
If it's higher than 5.
It has to be greater than 5.
So that means
If
it's up.
that's right. So if it's 5 exactly, it's like that teeter totter, right? Remember that kid?
Oh,
Okay, it's never been,
oh, yeah.
right? So this is 5 exactly, right? Because we're taking a look
Let
at
me
the number.
He's again.
fix my notes on that.
So the answer would be 23,100. That is the correct answer.
What's 100?
Okay? Okay. Okay. So when you guys are doing measurements, right? And this all pertains to measurements in general, that uncertainty. So a lot of times what we've done in the past, when we were learning everything, we would sit there and figure out how significant things were by where things were falling. So if I have a number that was between 0.6 and 0.7, and I'm using this ruler that I can't see anything on, right? It's not going to tell me too much. Technically, there's numbers there. I just can't see them, you know. So let me clear this out. It may help you see that there's pretend numbers here, right?
Oh, okay.
All right. Yeah, I can't see it. Yeah, it's really bad. I thought it was me. I'm like, man, my eyes are getting really, really bad. So, but we know that in theory, we're doing this measurement, and the answer that we're getting is between 0.6 and 0.7. Okay, so that length could be 0.6 plus or minus 0.1, or it could be 0.7 plus or minus 0.1. Right? We can't really sit there and tell. Okay, that's that uncertainty that we're talking about. Although this one is even worse because we can't see the numbers at all, right? So if we sit there and we go down, now we can sit there and get a little more certainty to it, right? So we know that this is it's less than 6.5 because the halfway mark between these two is roughly around here. Right? So I can sit there and say, well, you know, it could be plus or minus 0.01 meters in that case. It gives me a little more certainty, right? Because now I'm able to see those marks and I can clearly see that I'm a little below that halfway mark, right? Roughly estimates. But it's still uncertainty. Okay. So if we got down a little bit closer, we're getting a little more accurate with our values. Right? We get a better piece of equipment, we could get better results. Okay. So now I can clearly see that it's less than the 65, but it's greater than 64, just a little bit greater than 64. Right? So then I can sit there and say, a little more certainty, it's 64.3 plus or minus 0.1 centimeters. Or I can say it's 64.2 plus or minus 0.1 centimeters. And both of those would be good estimates because I have a better piece of equipment, I can see things better. So my certainty has gotten better. And so when we're talking again about sig figs, significant figures, we're talking about, in some cases, we have crappy equipment, right? Our scales aren't as good as others, right? Where if we went to Harnell, the Harnell has the top of the line scales, right? It's more accurate. They have better pieces of equipment. And so because of that, when we're sharing data, we have to take into account the uncertainty of our scales and also take into account the certainty of theirs. Since our scales are more uncertain, if we're trying to compare our data, we have to take in consideration that ours is not as accurate. So that means that if we look at everybody's data as a whole, it's going to be a little less accurate. And that's what that sig fig does. Okay, does that make sense? And really, it can be the difference between a drug being successful in clinical trials and not being successful by people taking into account people's significant figures, right? The data that's been collected.
So you're talking about like weight.
Yes.
Okay.
Yes. This is just getting down a little more nitty gritty, so I don't need to talk to you more about that. Okay, so we're refreshing, we're making sure that you guys got a clear understanding. Sig figs, number, how many sig figs are there? That first number. Great. Okay, what about the next number? Two. Okay. Like, man, I wish all the work was like this, right? Okay, we've already talked about how to round off, right? This is just an affirmation of everything that we talked about. And so here's a problem. So if it says a student weighs a beaker and 4 different chemicals using different balances, right? We do that all the time in this classroom, right? You start over here, you end up over there, you end up, So the individual masses and their sums are beaker 319.5 grams, chemical A 20.460 grams, chemical B 0.0639 grams, chemical C 45.64 grams, 642 grams, chemical D 4.173 grams, and the total after we add everything up 389.8389 grams. So what are we going to do? How are we going to determine the significance? We're going to line them up. So we line them up. Then we're going to draw our lines. Okay. Looks like I've been drinking.
What's that? You do that one.
You know. Okay, so A, B, or C. Which line are we going to use? A, B, or C?
A.
A. We're going to use the number before it or after?
No, excuse me.
After. So the 3?
Yes.
Okay, is 3 greater than 5? Okay, so then my answer. Okay. Questions? Questions?
How come there's only one line in the example?
What was that?
How come there's only one line in the example?
Because I was lazy.
Got it.
Actually, I could have sworn I had 4 lines there. But
Okay.
might have deleted them along the way. We've already talked about multiplication and division. We always know that it's going to be the lowest number of significant figures. Basically shows us that. So we have 3 sig figs here, we have 4 sig figs here, 4 sig figs here. So my answer should have 3 sig figs. Okay, so if we have a question where we have multiplication, division, addition, subtraction, you're going to use PEMDAS. I mean, PEMDAS. Thank you. Okay, so the metric system. We've already talked about the metric system. You guys are pretty familiar with it. You know that 1 inch is approximately 2.54 centimeters. 1 pound is approximately 453.5937 grams. Or we could sit there and say 1 pound is approximately 1 kilogram is approximately 2.2 pounds. And then 1 gallon is approximately 3.7854111784. So you guys are all familiar with the U.S. customary system. 1 foot, 12 inches, 1 yard, 3 feet, 1 mile, 5,280 feet. And then pounds equals 16 ounces, 1 quart equals 32 fluid ounces, 1 gallon equals 4 quarts. Okay, so a soft drink manufacturer converting from USCS units to the metric units. If the quart bottle initially is to remain the same volume, what number in milliliters should be printed on the label? So if you guys can do it in the drag and drop fashion, as ready from one unit to the other. What was that? Gave you nightmares. So we have 1 quart. In this situation, don't worry about sig figs. Technically, if you started off with 1 quart, that would be considered an exact number. So that's kind of like saying 1.00000000. Okay, what is my conversion? So we go back to the last page. Help us out. We want milliliters. We need gallons, liters. And we know that 1 gallon is going to be equal to 4 quarts. Did that help us?
Yes.
Okay, so I have quarts. How can I get rid of quarts? Okay, I need to put quarts under. So I have 4 quarts, and that's going to equal 1 gallon, right?
Right.
Okay. Now I have gallons. I know that 1 gallon equals 3.785 liters. Okay, but I want milliliters and I have liters.
So you gotta put it under 1 liter.
Yeah.
That's it. And then, 1,000 milliliters goes milliliter.
1,000 milliliters. Okay, so let's cross out those units. Make sure our units are correct. Okay, so we multiply the numbers on top. Then we divide it by the numbers on the bottom. What do you guys get? I know I give you the answer.
Yeah.
We can still work it out in the calculator to be sure that I'm right, because I can be giving you guys bullshit, right?
Very true.
I've been trying to teach you guys that. I'm gonna start giving you guys all the wrong answer.
It's gonna be 946.25.
Questions? Any questions? What's that? Yeah, I was lazy, I told you.
Got it.
So again, since there's an exact number that we're starting off with, I can use as many significant figures as I want,
Okay.
right? If I wanted to, I can go down to 0.2576597, whatever,
Right.
because it's starting out with an exact number.
Okay.
So anytime that you're given 1 quart or a quart bottle, that means that you're starting off with it. Questions? No questions? Good. Move forward, then we're gonna take we'll say a 15-minute break. Is that cool with everyone? Go potty. Yeah, hopefully I get right out of the parking lot. Walking groups, it's dark out there. Okay, so we're gonna start on temperature. Okay, so temperature. So there are a couple of scales that we use. What we use in the States is typically the Fahrenheit scale. And so these are some of the conversions that you want to keep in mind. You don't have to memorize them, but it doesn't hurt to know them because it makes it a lot easier to do the conversion. If you do. Okay, so water basically freezes at 32 degrees Fahrenheit. Water boils at 212 degrees Fahrenheit. Celsius scales, water freezes at 0 degrees Celsius, and water boils at 0 degrees, and that's a typo. It says Fahrenheit, it should say Celsius. See, I told you typos. That should be C. Okay, so when we're changing temperature, this is going to be the equation that we use. So, or you can use fraction 9/5, which is the same thing as 1. Okay. So if we go ahead and plug in, let's go ahead and plug in. So if it's TF, you're plugging in the degrees in Fahrenheit. So if we plug in Fahrenheit, so let's go ahead and plug in 212 into this equation. TF is equal to 212. What do you guys get for TC? 100. So this is what I always use to make sure that I have the equation right, just to confirm. I always do that checks and balance because I always remember that 212 water boils at 212 or degrees Fahrenheit or 100 degrees Celsius. Okay, so we also have another, it's called Kelvin. Kelvin is based upon the absolute zero scale. And so T Kelvin is going to be equal to T Celsius plus 273.15. Your book sometimes get lazy and just says 273. So, but it really should be 273.15. If you guys look at the video that I make about how to do it using Excel, so for your Mentos experiment, you guys will again have access to that. I'll be uploading it tonight, and we'll have until next Wednesday to get your lab report done. Now, if you look at that, I said 273.15, but I typed in 273.25. Make sure you guys don't make the same mistake that I did. Yes, thank you. That's what I was just saying. So they've seen the video. Okay. So, but it should be 273.15. Really, I can't remember if I was drinking or I had drink at that point. I might have been. So that's what happens when I make videos on the weekend. Okay, so this is just basically showing you that. Now, this is how those scales compare to one another. And again, you'll notice that how Kelvin is set up, it has that value that we can go to absolute zero. What happens at absolute zero, by the way? Said it. Anybody remembers at Harnell? Did anybody remember what happens at absolute zero? You don't think I said it? I might have not said it here. I know I said it in Harnell at the last lab. Actually, I said it here for the last lab too. Should have been here. I know. Did you text me?
I campus, yeah.
You didn't text me. You emailed me.
Well, in campus, it's like a text. Like you get notified from your email and campus tab.
Oh, okay.
Yeah, so it's like an email and a text.
But he didn't text me. Text me.
Okay, nice. No, it's
Yeah, because it goes to my email and then it goes to that pile of
God.
emails that I
I
have.
see. That's why you take this one.
Anyone? Oh, I do have an answer there. I have 20. All right, Max. Max says movement totally stops. That is correct. Yes, movement totally stops. Okay, so with movement totally stopping, let's go ahead and take our 15-minute break. I will see you guys back here at, what is it, 8:35. I'll see you guys back here at 8:35. Okay.
I don't think I got the paper notes.
For the last chapter 3. Okay. So those were the very first notes. Let's see if I have an extra copy. Go, make it the lights on. Make it the lights on.
Yeah, overall. Change school system. Yeah, basically, yes, like 6 through, pretty much 6 to K. So you know, yeah.
Like school.
It says it's up today. Go to Starbucks to get coffee. Go to the bar. Take a couple of shots.
Should told me what the discount.
I thought you were talking about the bar, like, okay, let's go.
I don't know all that.
There's a question for me for Parnell. So yeah, I posted 3 lectures. If you've come to this lecture or you came to last week's lecture, then you don't have to watch the lectures. These are just recordings of the lectures. And some of them are recordings of labs that I talk about certain things that may be important for you. If you come to the lab or attended the lab, you've already seen some of it. So
So am I good? I can leave?
just foresee the material. Does that help, Stephanie? She's probably on the break right now. Oh, you're there. Good.
Is this a repeat lecture or should I just go? Because I went to the other two.
No, this isn't the repeat lecture. This is the new lecture. The repeat lecture will be tomorrow.
Oh, from this recording, of course.
So this will be, yeah, because we've covered all of almost covered all of chapter 3.
Oh, okay. Because on the third, I believe it was Thursday, I didn't go in the last 30 or 40 minutes. So I didn't know if this was the rest of it.
No, that one is we didn't, if you looked at the recording, last
I
part.
haven't looked at it. I was too busy doing the Mentos, all that graphing stuff.
Yeah, but we kind of recapped a lot of the things that we talked about, so you should be okay.
Okay.
By being at this lecture.
Yeah.
But we still have more stuff that I'll be introducing.
Okay. Are you going till 9 or you're going over?
This one goes to 10.
Oh,
So-
yeah. Yeah, totally. I'm thinking of work right now. I'm sorry. Okay. All right.
We're almost there. A minute, we'll get started. So remember. I think I have power to the wall. Is it plugged in? My world. Okay, you guys ready? Let's get started. Party. I'm ready. Me too. Coffee, can't mistake. Okay, so first thing that we're going to do is convert from 288 Kelvin to Fahrenheit. So how am I going to go about doing that? Are you sure?
It's,
Yes. Money on. Last I heard it's like $500 to run your rate.
See, that was her bet.
Oh,
That was
okay.
her bet. That's her bet.
So remember, it's in Kelvin. What is the conversion from Kelvin to?
it's Celsius.
So we have to go to Celsius first, right?
Oh.
Okay, so how would I convert from 288 Kelvin? So what is that equation to change Kelvin or Celsius to Kelvin?
It's
You don't have that one, or are you
You
sure?
add 273, right?
Yes, so a Kelvin, T Kelvin, TK equals T Celsius
Point.
plus 273. Don't make the mistake I made, 0.15. And the funny thing is that I said 0.15 and I wrote 0.25.
You're human.
Yeah, it's gonna happen. Okay, so now that means we have 288 equals TC plus 273. 5. And we're just gonna solve for TC. So we're gonna subtract both sides by 3.15.
So it's 288 minus 273.
No, minus.
Oh, minus.
That's a minus. Sorry.
Oh,
Making fun of my third grade handwriting. Ah,
just making sure.
So then we get TC is equal to okay. Now that's Celsius. So how do I go from Celsius to Fahrenheit?
That would do the times the 1.8 divided by 32. Okay.
Okay. So it's 1.8 times TC. Right. Plus 32. That's going to equal T Fahrenheit. So we're changing that equation around since it was T Fahrenheit minus, T Fahrenheit minus 32 divided by 1.8.
One point eight plus 14.85.
No, it's 1.8 times 14.85.
Oh,
Yeah. Eight point 7. Okay. What you guys got? Yes, no, maybe?
Just a little one.
What was that?
Because that first problem TF, you already rounded it to 15 instead of just putting 14.5.
I didn't put 14.8.
Oh, you did?
Yeah.
I don't know.
Let me check. $58.73. So 1.8 times 14.85, and then you add plus 32.
Didn't roll one.
What was that?
I was doing roll one.
Oh. Yeah. Okay. Any questions? Any concerns? You had a question?
So you round it up.
Yeah, at the end, I end up rounding it up. Same things. Okay, so can you guys fill out this table for me? I know it's on the thing. Now I'm gonna start taking a while. I did. The math question.
Ready to fill all those things.
So I know all the answers are there, so let's work through them together. Okay? Okay, so we have, what was that? So we have negative 25 degrees Celsius. So I want to change that to Fahrenheit. How do I do that? What is the equation? We multiply it by 1.8. Okay, 1.8. Okay, so I got negative 45. And what am I going to do with that? Add back 32. I get negative 13. Okay. How do I change it to Kelvin? Okay. So I add 20, negative 25 plus 273 point, and I heard you mess with me. 1.5.
Yes, sir.
You're just waiting till I caught that. $248.15.
Yep.
Okay, what about starting with 105 Fahrenheit? Somebody else. How am I going to change that to Celsius? TC.
It's 28 minus 32 divided by 1.8.
Okay, so 105 minus 32 divided by 87.2. So 105 minus 32. 105 minus 32 divided by 1.8. One oh five minus 32 divided by 1.8. Let's do 1, 2, 3. 40.6. How do I change that to Kelvin? A is going to be equal to our answer in Celsius. $40.6 plus 273.15. Three, 7. Okay, and then our last one, we have 364 degrees Kelvin. Change it to Celsius. How do I do that? 64
Minus
673.15. $90.85. Okay, and how do I change that to Fahrenheit? Okay, so our TF equal to 1.8 times 90.85
plus 32. Five. Questions? Concerns? Okay. Okay. Guys are awfully quiet today. You act like it's a Monday. You know it's hump day, right? We should be celebrating. Okay, so sometimes we have to calculate the change in temperature, right? So typically when we calculate the change in temperature, this symbol delta, this is the Greek symbol capital delta, which means change. So delta T is going to be equal to T final minus T initial. Or are we the end temperature minus the starting temperature? Determine the change in temperature when water drops from 32 degrees Celsius to 60 degrees Celsius. Okay, so my delta T is going to equal T final minus my T initial. Okay, so my T final is what temperature? 6 degrees Celsius.
I see.
Minus
32.
32 degrees Celsius. Is it going to be 26 or negative 26? Okay. Yes, I should probably clear this up to the next slide. So, proportionality. So, often we'll be talking about proportionalities. So things are considered to be directly proportional when they both go up. Okay, so things are going to be considered directly proportional when they both go up, and they're going to be considered indirectly proportional when one goes up and the other thing goes down. Okay, so let me give you an example. So if we talk about density, so we have density is equal to mass over volume. Okay, so we say that mass, M standing for mass, is going to be directly proportional to volume. So as the mass goes up, the volume has to go up. Density is always going to be a constant. So let's assume that we're talking about water. I'll give you a great example. So does anybody remember the density of water? Yes, it's a slab. 1. Okay, so the density of water is 1. It's 1 gram per milliliter, right? Okay, so if I have 100 milliliters, how many grams must I have? If I have 1,000 grams of water, how many milliliters must I have? 1,000 milliliters per liter. Sure. If I have 25,000 milliliters of water, how many grams must I have? $2,500?
It's the same amount. Oh.
Because it has to equal 1, right? Okay. It's not 0, so you guys don't think it's a 6. Okay, so if you notice, as I went up in volume, my mass went up, right? So those guys are considered to be directly proportional to each other. So usually if they're on the same side with each other, they're going to be over each other.
Okay.
Okay.
So milliliters and grams are the same thing.
No, they're not the same thing. They're not saying that they're the same thing. They're saying that the density of water
Oh.
is millimeters over grams.
Okay.
And so all I'm saying is that they go up together. They're going to increase together.
Just for density.
Not for density. Yes, for density,
Okay.
they're always going to be directly proportional to each other. Yes.
Okay.
Okay, so let me give you an example of indirectly proportional. So we have pressure and volume. Okay. So pressure and volume, when they're multiplied together, they basically equal work. Work is also going to be considered like a constant. Okay, so in this case, we're saying the constant work, whatever it is. So we're going to say it's going to be 100. Okay, so K is going to be 100. Okay, so if my volume is 10, B equals 10. B stands for volume. Then my P is going to equal what if my work is going to be 100? Liters, we're going to use liters atmosphere as our unit. So if all together has to equal 100, so then how much? Are you sure? So if we're multiplying 40 times, pressure times volume, P equals pressure. And V equals volume. So we're multiplying them times each other. And my K equals the work, okay? So if P times V equals K, so then what must K be what must P be if I have a volume of 10? So it has to be 10, okay? So P is equal to 10. Okay. So if my V is 1, what must P be?
1. What if V is 1?
Now remember, K is always constant. So in other words, K is always going to be the same. K is always going to be 100.
Okay.
Right? So now I'm putting in 1 here. So K is 100. K is 100, and I'm putting 1 in here. What times 1 is going to be 100? 100.
I don't know. Okay.
Okay, so then that means my P is going to be 100. Okay, now if my V is 0.1, then my P must be 0.1. So what can I multiply by 0.1 to equal 100? So 0.1, we'll write it out, 0.1 times X, X being my unknown, is going to equal 100. So tell me what X is. 1,000. So then that means my P is going to be 1,000. Okay. My pressure is going to be 1,000. Okay, so if you notice, my volume went from 10 to 1 to 0.1. What happened to my pressure? Did it increase or did it decrease?
The pressure increase.
It increased, right? So this is an example of indirectly proportional. One goes up, the other one goes down. So if those two numbers that we're looking at are on the same side, or those two factors are on the same side, multiplied by each other, right? If they're multiplied by each other, they're going to be indirectly proportional. That means one is going to go up, the other one is going to go down.
Okay.
Okay. If they're divided by each other and they're on the same side, they're going to be directly proportional.
We kind of cancel out, right?
That's right.
Got it.
Exactly.
Got it.
Okay. So this here is an example of indirectly or inversely, versely or indirectly. And you'll see both used, inversely or indirectly. They're a great hanger. And then this guy is an example of directly or direct proportionality. Okay, so directly basically means they go up together, right? Both values are going up. Indirect or inversely, opposite. Okay, good job. Gotta give the chat screen more often. Can I clear? Everybody got all my gibberish?
Yep. I'm good.
Okay, so this is just basically showing you everything that we just talked about. So mass and volume are proportional to each other. So this symbol here basically means some type of proportionality. To make it exact, we need a constant. And density is that constant. So these are called, density is going to be our proportionality constant. It makes it so that they're equal to each other. So then that's how we can say density is going to be equal to mass over volume. Okay. So density is going to be expressed in grams per milliliter, or you're going to see it expressed in grams per cubic centimeters. Sometimes you'll see expressed in grams per liters. So density is going to be temperature dependent. Why do you think density is going to be temperature dependent? So in other words, the density of ice is going to be different than the density of water. Why do you think that's the case?
Because one is solid and one's liquid.
Yes, because of the phases, right? Wow. Thank you. Oh, you see everything that we talked about? So it's good that we're not talking mess about everybody. Okay, so in this case, we have water and ice, right? So ice is going to have a nice little organization, but you notice ice also has that little gap in between, right? It's going to be very organized. Now, this is the reason why ice floats. It's because of that little gap, right? Where water is all, you don't have that gap. It's all over the place, you know. And so because this is nicely organized, it gives us that little gap, it gives us that air, it causes ice to be lighter than water. So that's the reason why ice floats. Okay, so here's an example of ice floating. Now here's an example of us freezing ethanol. Ethanol doesn't form that nice little ring structure where you have a little gap in it, right? It forms this nice little solid that's hard. So if we freeze something total ethanol and drop it into just ethanol, it's going to sink to the bottom because it's going to be greater than what you see with the ethanol. The density is going to be greater. Okay. So here's some common elements or common things that we come across and their densities. So you guys can see the density of helium is lighter, the density of helium is less than air. So why do you think helium balloons float? Let's do that in the lab. Anyone? Anyone?
Repeat the question one more time.
Why do you think helium balloons float? Okay, now, so if your density is heavier, right, than what you're in, then that means that you're gonna sink, right? So if the helium balloon has a density of 0.00717,
Because the molecules have more space.
Lighter than air.
okay,
Yeah.
yes, because the density of helium is lighter than the density of air. So since density of helium is lighter than air, it's gonna float.
Like, you say that the ice has this gas, that's why they float, right?
Yeah.
And I'm like, okay, and why do we float on water? And but that's the answer, because there's more water
So
than my
you-
body, so you can float.
No, there's more air. You have air in your body, so you float. So for instance, let's say, for instance, when you die, right? One of the reasons why we float is because we can suck up air, and then, but if you die, you stop sucking up air. You initially start sinking, but over time, you'll start floating. Why?
Yes.
Because of the gases that you're generating in your body. So as your body is being decayed by bacteria, it starts making more carbon dioxide. It makes those, then as a result of it, you become lighter than the density of water, so you start to float. Okay, so since helium has a lighter density, it's gonna float, right? Like ice has a lighter density than water, so that's why it floats. So ethanol cube, when it's frozen, an ethanol solid, it's gonna sink because it's heavier than water and it's also heavier than it's heavier, actually, it's heavier than the ethanol. Okay, so why do you think wood floats? Because it's lighter, right? Okay, so you guys get how it works, right? So if your density is lighter, you're gonna float. So if I put lead in water, what's gonna happen? It's gonna sink. Everybody went fishing. Yes. Yeah, and you use lead weights, so it sinks. Okay, good. Okay, so the mass of 50.00 milliliters of sample of methanol is 39.59 grams. Determine the density of methanol. What is the equation for density? Density is going to equal mass. Okay. So our mass here is
No, it's
39.
50, it's 50, oh, it is.
Mass, it's
39,
Completely.
59 grams. Okay, and then volume is 50.00. How many sig figs should I have?
4.
I should have 4. That's right. So what did you guys get? That's right, grams per milliliter. Questions? No questions, good. The density of a certain machine oil is 0.910 grams per milliliter. Find the volume occupied by 196 grams of that oil.
So if you wanna find the volume, like density by mass.
Okay, so we're going to go density times. Is it gonna be times mass? So we're saying volume. Okay, so let's look at the equation. So we have density is equal to
Mass of
mass over volume. And we're looking for volume, right? So then we're gonna bring this over on this side. And then we're gonna bring this on the bottom, right?
Oh,
Right, so then we're gonna have volume is equal to mass over density. Okay, so B is gonna equal to 196 grams over 0.910 grams. Grams are going to cancel out. And we're going to just do that for milliliters since we converted. So then our answer is going to be how many sig figures should we have? I should have 3. Okay. 50.
215.
215. 250.
But it's only three.
Yeah, so you let the
215. Okay. Questions?
will there ever be a problem? You have to find the mass,
Yeah,
and then will we use the same kind of.
same concept, but the implication is solving for mass instead of solving for volume. Okay. Okay, quantity. So we kind of talked about quantity before. So we've already talked about a dozen. So I have a dozen of roses. How many roses do I have?
12
I have a dozen of cousins. How many cousins do I have?
cousins.
I have a dozen of girlfriends. How many girlfriends do I have? Okay. So in chemistry, we use the mole, right? And we've talked about this class. So we know that 1 mole is always going to be equal to 6.022 times 10 to the 23rd. Okay, and that's a mole of anything, right? So I can have a mole of atoms. How many atoms do I have? A mole
Oh,
of atoms.
6.002.
there's one there.
Okay, 10 to the 23rd. Yes, that's right. So regardless of what I'm talking about, if I tell you I have a mole of it, that means 6.022 times 10. Okay. So the mole is basically based upon 12 grams of carbon. So 1 mole of carbon is going to be equal to 12 grams. Okay. Now, what they did, they actually counted how many atoms of carbon there were in that 12 grams. And it ended up being 6.022 times 10 to the 23rd. And this is called Avogadro's number.
You said 1 mole equals 12 grams of carbon.
Yes, 1 mole. 1 mole equals 12 grams. Okay, so often
12 grams of carbon, okay? We also know that 1 mole equals how many atoms of carbon? So 1 mole of carbon is going to be 6.22 times 10 to the 23rd. Atoms. Okay. So moles is going to be quantity, grams is going to be mass. But we have this way of converting. Now, on your periodic table, you guys are given the molar mass or the atomic mass of an element. Carbon is 12. It's 12.011 grams. Something like that.
It's like 12.01.
Yeah.
I think you got it right.
Okay. So, but we know that that is going to be, in terms of quantity, that's going to be 6.022 times 10 to the 23rd.
Okay.
So do you guys see the distinction between quantity and mass? Let me see if I can make it a little more simpler. So I make a bomb assay. In summer, typically, right? You guys know what sangria is? Yeah? Anybody not know what sangria is? Okay, good. Everybody knows what sangria is, okay? So for my bomb ass sangria, if you want to write this down, it's important. Okay, so I start off with 3 apples. Okay, I cut up my apples, but they're 3 apples. Okay, okay, you guys write this down. It's important because I'm going to come to your house and I want you to make my bomb ass sangria.
Okay, okay.
I should ask first. Do you guys want the red sangria or do you want the light sangria?
Wait, what kind of apple?
So it depends. It depends on whether we're having the red or the white.
Personally, like red, so let's go red.
You go like red? Okay, so if you're going with the red, you gotta go with delicious if you want it to be sweet, right? So delicious or honey crisp, those are your 2 choices. Okay. So I take 2 plums, they have to be a little firm, and I cut those up. 2, okay? So I then get frozen strawberries that's already sliced. Now, if you think about a small bag of frozen strawberries, it's going to have anywhere from 25 to 30 strawberries that have been sliced up. Okay. Then I get a bag of blueberries. A bag about this big, it usually has about 75 to 100 blueberries. Okay. Now I put those in there, but I forgot to tell you one thing. I put in about, say, a 1/5 of vodka. Okay. So you put the 1/5 of vodka in there, and then you put your fruit in there. Let it sit. Okay. So we have strawberries, right? How many strawberries did I say?
In a bag?
So 25 to 30 is the bag, exactly. So how many blueberries?
70, 75.
70, 75 to 100. Yeah. Yep. How many apples?
3.
How many plums?
2.
2. Okay, so then I also
And a
get,
bottle of water.
yeah, and a bottle. You can put a whole bottle if you really want to really turn up, you'll put a whole bottle, right?
It was a bit.
Okay, so then I get they're called blood red peaches, right? And they're really, really red, blood red peaches. So you want to cut those. You can just get the normal peach, that's fine, but the blood red are like they're juicy and they're really good. So, and you're gonna need 4 of those. 4 of those. So that's like the finishing touch, right? Okay, so then, as I said, you let it sit for a little bit, let all the alcohol absorb. And then I make my own wine, but I typically get a fruit wine or or you can get something like a Merlot. You don't want anything that's too spicy, right? Because the spice kind of kills that sweetness in the crisp. But like a Merlot or get a fruit. That's what I have, like I said, I have various types of fruit wines in my garage right now. So. Okay, so then you just pour it in there and you let it sit. Okay, and then let it sit overnight so it kind of soaks in really well, and then you're ready to serve the next day. Now, beauty of it is that the fruit has absorbed most of the fortified alcohol. I guarantee you, you're gonna have a great time. Everybody at your party is gonna love it, and they're gonna be eating the fruit, right? So the fruit is gonna get messed up. The wine is just kind of the passage for the fruit. Okay, you want to make sure you have enough fruit, and then when the bottle gets low, it doesn't matter. Just pour another bottle in there because it's the fruit that is the secret. Okay. Now, at any point did I say, wait? No. Okay. So this is important for chemistry because we want to avoid waste. We work with quantity. We're thinking about quantity, but we have to weigh things at certain points to get to quantity. So we need to be able to go from mass to quantity. And that's what the mole helps us do. Okay? You guys get it? And you guys understand that they're different from each other. Okay? And you got a recipe for sangria. Okay, so we're gonna switch gears to chapter 3. You thought you were gonna be done. Not chapter 3, chapter 2. Chapter 2 should go pretty fast because you guys got the hard stuff. Kind of how to make. Okay, so chemistry is the study of matter. And if you think about matter, there are three ways to think about matter, right? One of them is macroscopic. So macroscopic can basically be seen with our eyes, right? So, or we think of it macro. Macro is going to be big, okay? The other one is microscopic. Microscopic means that we have to use the microscope to look at something. Just the other day, we were looking at yeast, right? In our 10th class, in my other class. They don't get that. Okay, and then the last way is particulate, or things that are small. So they're so small that we can't use the classic microscope. We talk about microscopes, we used to talk about the microscopes that we had in lab, we call them light microscopes. So particulate, we're going to have to use specialized microscopes. So that's going to be like scanning, tuning microscopes. That's going to be electron microscopes. So things like that that allows us to look at things that are really, really, really small. Okay, so if we think about the macroscopic, that's going to be like us, right? It's going to be the ring on your fingers, things that we can clearly see with our eyes. Okay, if we think about microscopic, it's going to be like a cell, a yeast cell, a bacterial cell. Okay, and if we think about the particulate, that's going to be something like a virus, proteins, compounds, okay, or just the atom. Work for me.
I don't have the chapter 2.
You don't have a chapter 2 packet. Okay. Let's see if I can get you a chapter 2 packet. Okay, because we're going to be talking about the particular level, we're going to be talking about compounds, and atoms. And I don't know about you guys. Anybody here can actually see a single atom of water? Anybody? If anybody can, let me know, because we can make a lot of money off of this. Okay, so since none of us can do that, we have to visualize things, right? We have to find ways of visualizing it. One of those ways is by using models. Okay, so in chemistry, we use the model quite a bit. If you guys can do me a favor, in the center here, there's a box. Looks like this. Pick up that box for me. Pick up a box. There should be, we have some more on this side. I don't know if we have it out for it. Same one that has it. There's some over here. Anybody not have? I know you guys at home. But go left, yeah. Anybody else not have? You guys don't share. Got shares over there. Sharing is sharing. Okay, good. So what I'd like you guys to do is take out a black one that has 4 holes. Now, I want you to take out 4 white ones. Then take out 4 of the light gray sticks. Or rock. Yeah. Okay, so these models are called the ball and stick model. So you guys can see it on the screen here. The ball and stick model. Okay, so what I'd like you guys to do is build that model that you guys see on the screen. So this model is methane. Methane is very popular here. Smell it every day you drive in. What is methane? What is the biggest source of methane? What is that? It's a gas. Yes, it's a gas. What is the biggest source of methane? What was that? Did you say a fart? That is correct, a fart, particularly cow farts, right? So we get a big whiff of it since we have a slaughterhouse, I mean, a ranch. A ranch up the road, okay? So we get a lot of that methane gas as a result of it. Now, we can't see a single methane molecule, but we can use these models to help us visualize it. What you guys have basically done, have built a methane model, okay? And so again, the model that you build is called the ball stick model, okay? Ball and stick model. Often, when we're using 3-dimensional structures, we do the space filling models. So you'll see both of these used frequently. The ones that we use with our hands, the ball and stick, it makes it easier. We also will use drawings. And so you guys need to get used to looking at it and kind of visualizing that these molecules are 3D structures. So if you guys take a look at it, is it a single plane or is it a 3D structure? It's a 3D structure, right? So this, the shape of it is what? What of this structure? What is the shape? It's a tetrahedral. So we have names of the different types of shapes. And we'll be talking about that a little bit later on, but I just wanted to introduce you to it. Sometimes it works, sometimes it doesn't. So that model is representing a compound. So the chemical formula for this compound is, I've got to write this on the sideboard here.
it's CH4, right? So we know that this here is our chemical symbol. That chemical symbol C stands for carbon. So we know that that's carbon. We know that the H stands for hydrogen. Now, this here, you guys remember what this is called? That number there? That's right. It's the number of hydrogens that we have. So this is called the substrate. Okay, so if there's no number here, it's understood to be 1. That means we have 1 carbon and 4 hydrogens. Altogether, this makes up methane. Okay, now you notice how I wrote it. We have a capital C and a capital H. I didn't write it like this. Or like this. Okay, because we need to be sure of what we're talking about. So we want to make sure that we write the symbol correctly. Like, let me give you an example. So if I write a P and a capital O versus a P and a lowercase o. P capital O means that I have phosphorus and oxygen in my compound. PO, can you guys do me a favor? Look at your periodic table. And you tell me what capital P lowercase o is. Polonium, right? So if you gave me a polonium and I wanted phosphorus oxide, I'd be a little upset because polonium is radioactive, right? So you just giving me a radioactive element and you're just handing it out like candy, right? So it's important for us to know what you're writing. So you want to make sure that you're writing the chemical compound correctly because you could be writing something else. Okay, and so you'll notice with our symbols, some of them will be a single letter, some of them will be 2 letters. So if it's 2 letters, that first letter is going to be capital, the lowercase. The second letter is going to be lowercase. Okay, so let's take a look at this. If I have BR, capital BR, what element is that? BR. Bromine, right? If I have NP, capital N, capital P. Phosphorus, right? But if I have capital N, lowercase p, that's Neptunium. Yes. Okay, so it's really important that we do that. And you wouldn't believe how many people, it's the thing that drives me crazy, right? And I tell you guys, so please don't do it. It drives me crazy. It just drives me crazy, right? And not only that, I'm like, do they understand that this could be something entirely different? You can destroy the world just by you writing the wrong thing down, right? So you want to pay attention to that, right? It's really, really important, okay? So are we good on this? Everybody got it? You see why it's important to see this distinction? Not full of the world yet, right? Okay, so you guys are familiar with, now you understand the chemical symbol. Okay, so if I have H2O, everybody knows water, right? H2O. How many hydrogens do I have? How many oxygens? Okay, now water is always going to be H2O. So if I write H2, O2, is that water? No. So that would not be water. This would be hydrogen peroxide. It's different, it's going to react different. If you pour water on your wound, what happens?
Oh, I think it washes it out.
It washes it out. If I put hydrogen peroxide on my wound,
That's what.
oh, it bubbles, right? And it stings a little bit, right? So there is clearly a distinction between hydrogen peroxide and water. They're not the same thing. So it's really important for us to understand that when we're talking about compounds. That's a compound. Hydrogen peroxide is a compound. Water is a compound. They're two different compounds. Okay? Okay, so we've already talked about the different states. What are the different states of matter? Liquid, solid, and gas. Okay? We've talked about the kinetic molecular theory. The kinetic molecular theory basically means that particles are constantly moving, right? And so, and they're going to move faster when? When are they going to move faster? Well, we know they're in constant motion. Okay, so let's say, for instance, we're solid, right? Now, a solid is moving, right? But is it moving fast? Solid?
So we're solid.
I say, if we were solid, are we gonna be moving fast? Right? So, if we're solid, if anything is a solid, if something is a solid, cube of ice, is it moving? Do you see the molecules moving on the table? Right? Do me a favor. Is that water? Okay, so we have water, right? We'll find out here in a bit. Okay, so I should, okay, take a little bit, eh? Okay, so we have water here, right? So in the case of water, does water move?
Yeah.
Does it move freely?
Yeah.
Right? Now,
Yeah, it is open.
I know, that's why I've explained everybody with it, right? Okay, so we know that it moves. If I have a chunk of ice, is it moving? The only way it moves is if I throw it at somebody, right? And that's different, right? And so we notice that their water is more movable than ice is. Why?
Because the water is a liquid.
Water is a liquid. Okay, so we established. So if we go from a solid to a liquid, we get a little more mobile. So why is that? Why are we becoming more mobile? What was that? So you're saying the compounds are loose, they're flying around. So they're not so tightly held together, they're not neatly organized, right? They're not solid, okay? So, but, what was that? There are gaps between.
That's why they move more readily.
Well, there's gaps between the ice too, that's why ice flows, right? Remember we showed that picture of ice earlier? Okay, so we're getting somewhere, we're making some progress here. Okay, so you're telling me that we're getting movement because we went from a solid to a liquid. So how do I go from a solid to a liquid? Heat. Heat. Okay, so we established if there's heat, we go from a solid to a liquid. So I'm gonna ask you this. So if there's heat, are those molecules moving faster or slower?
Faster.
Faster. Okay, so if we kind of like thinking about it, we're on a beach, right? And that beach has hot sand. And so we're on the beach has hot sand, we're walking to the water, are we?
No.
We're running to the water, why?
Because it's hot.
Because it's hot, right? So in that case, heat causes us to move fast too, right? Because we want to get cool, we want to get to that cold water. So we're racing to that cold water. So that introduction to heat causes that change in phases. So if I put more heat into it, what happens to my water? What happened to the water when you guys on Monday? It would, right? And so then it became steam, right? And it started occupying all of the space. And we know that in that case, it's moving faster. How many of you guys have been to a nightclub? Long time ago? You been to a nightclub? Anybody else been to a nightclub? Have you ever been to a nightclub? Oh my gosh.
Oh my God. He's like
Okay.
younger than you.
Okay, so, but you've been to a party. Everybody's been to a party, right? Quinceañera, wedding. Okay, good. Okay, so have you ever been to a party or a wedding or something where there's a whole bunch of people. The place is packed. It's like jam packed, right? Okay, so now when it's jam packed, are you dancing wild and crazy? Or are you doing the cute dance? What are you doing?
Very cute dance.
The cute dance, right? Because there's not a lot of room. You're packed together. So in the case of a solid, it's packed together. Not a lot of room. So you're not going to get a lot of movement. You're going to get a little vibration. You're going to get the really cute dance, right? But then in the case,
Oh, is that why like when someone's cold, like their body starts shivering to try to get movement?
yes, exactly. Try to warm up a little bit. Yeah, that's why we shiver. Good job. That's a physiological effect. That's a class over there. Right? Good job. You guys you're already planning for the next classes and everything. Yeah, that's good. Okay, so in the case of the liquid, right? In that case, you have room to dance, right? And so there's a little more room, so you can do that line dance, right? You know, hey, you can sit there, and everybody's doing it with you, you're in sync and everything, right? Okay, so that's kind of like that liquid. You're also moving a little bit more, right? You're moving a lot more than what you're moving in the case when you're a solid. So when you're a gas, you have the whole place to yourself, right? Nobody around, you're acting cool. Yeah, woo, 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 yeah, right? And you're really moving, right? Okay, so that is the concept of the kinetic molecular theory, right? It's that concept of things are moving and that we're able to change phases by introducing heat, or what we call energy. Right? So we have gases, we have liquids, and we have solids. Solids vibrating just a little bit. Now there are two types of solids. We have the one that's really, really organized. It's called that crystalline solid, right? Crystalline, it sounds organized, right? Crystalline, right? Crystalline, organized. We also have amorphous. Amorphous means lack of shape. Have you guys, anybody sci-fi fans? Sci-fi, right? You heard of morphs, right? People that change shapes, right? So amorphous, lack of shape. Okay, so that's a good way of remembering.
Isn't there a villain named Amorphous?
Amorphous, yeah, because he didn't have any shape, right?
Yeah.
Yeah, it's just like, yeah. Okay, so liquid, those molecules are going to be touching each other, but they're going to be able to be freely moving, right? And then in the case of the gas, they're going to be so far apart, and then when they do come in contact with each other, they're just going to bounce off of each other, right? So it's just going to be wild, right? So the three states of matter, we have solid, liquid, and gas. Okay, so in the case of, my camera is not on me. I gotta fix that. Okay, in the case of a solid, right? If we go from a solid to a liquid, we call that melting, right? If we go from a liquid to a solid, we call it freezing, or we call it fusion. Okay. If we go from a liquid to a gas, that's called vaporization or boiling. If we go from a gas to a liquid, that's called condensation. So this is the one that nobody ever remembers. If we go from a solid to a gas, that's called sublimation. There's a band called Sublime, right? Because they're all about gas, man. Okay, so if we go from a gas to a solid, that's called deposition, or your deposit, right? Okay, so energy is required for all of these to take place. For us to change phases, energy is going to be required. Okay. Questions so far?
So when we sweat, it's our body like trying to force it. Kind of like shivering.
Yes. So when we sweat, that's our body
So that's
trying to.
condensation, right?
Yeah, in a sense.
Okay.
Well, so it's sort of evaporation, because if you think about it, initially it's coming off, but it's also that condensation, so coming back down. So yes, so you're getting a little bit of both going on.
Okay.
But good point. Trying to see if I can get the camera to follow. Okay, so here here's basically our gas, here's our liquid, and here's our solid, right? And in the case of our gas, the gas is going to be kind of dependent on that container that we're in. So it's going to be bouncing off the wall and everything, but it's going to try to occupy that full container, right? So if we have a bottle of gas, it's going to occupy that whole bottle of gas. It's kept. Okay. Now, the volume is going to be dependent on that container that we're using. It's a closed container. But if it's not a closed container, then it has access to everything. So it's going to be as huge as possible, right? Because it wants to occupy as much space as possible. When we're talking about volume, we're talking about space that's being occupied, right? So if we have liquid, we have that bottle there, bottle of water, right? So is it occupied? Is this bottle that's half full or 2/3 full, is it occupying the whole volume? Is it? What about all the stuff up top? It's not. It's not. Because then I have room for it to flip over, right? Okay, so it's only going to be able to occupy that bottom of that container. If there's nothing there, it's going to run all over the place, right? And then the solid, if I have a chunk of ice, and I put it on the table here, is it going anywhere? It's going to keep the shape that the chunk was originally in, right? Okay. So in this case, its shape is going to be rigid, its volume is going to be rigid. It's going to be constant, right? We know the particles are going to be vibrating. They're going to be vibrating in a fixed position. They're going to be that cute little dance, right? Where here, they're going to be moving a lot more, right? And then here, they're really going to be moving in the case of the gas. Okay? Okay, so we talked about physical change, right? Physical change. What is physical change? Or a physical reaction? What's that?
It's no longer cheap.
It's no longer what?
It's cheap.
It's shape. It's shape. Okay. I was like, my friend. Yeah, no, it's okay. I get it. I'm starting to get sick too. I'm blaming you because I don't know why, but I'm blaming you.
Okay.
Yeah, okay. Okay. So a physical reaction. So how can I define a physical reaction? You say shape. Is there anything else? So what do you mean by that? Elaborate. Okay, so if it's square, it's always a square.
It's no longer a square.
It's no longer a square. Okay, so when it's a square, it's no longer a square. Okay. Okay, so a square becomes a rectangle.
Yeah.
Okay, so is that the way that I would define a physical reaction?
It will be like that, no, the eyes that you said that you're gonna put on, it's on a form or a shape. Or whatever. It wants to smoke it.
So if my ice was a heart shape, that's what you're trying to say. My ice was a heart shape, and then we melted, right?
It will leak, it will
What was that?
change it.
But it's still water. So if it's ice and water, it still has the same chemical formula. So it's still H2O.
Well, yeah, but the physical, the physical.
Characteristics.
Yes, it's not the same. because
So
one
that's
is
what you're
solid,
trying to get. The physical characteristics.
now it's liquid.
Okay, so the physical characteristics change. So in the case, the chemical characteristics are exactly the same. The only thing that we're changing are the physical characteristics. Okay, sounds good. Sounds like a really good. You guys really thought about that. That's really good thought, right? Okay, so you guys did submit those experiments. So was that a physical reaction or was that a chemical reaction? Okay, how many people thought it was a chemical reaction? Raise your hand. How many of you guys thought it was a physical reaction? Raise your hand. You guys at home, I mean, and Harnell, you guys can vote in this too because you guys did it. Physical or chemical? You got physical. You think it was physical? Okay, got two physicals. Everybody votes. Remember, this is democracy. Everybody votes. Or you get points deducted.
Oh, yeah, that's what I said. Anybody, both. Okay, I can even do both.
Good, physical. Okay, so the way I like to think of it is if I can recover anything that's lost and put it
exactly the same, then it's gonna be a physical reaction. Could I recover what was being lost? What was being lost in this case? We're the liquid, okay, anything else? Gas, primarily it was the gas that was causing the liquid to shoot out, right? So what gas was being let loose in the case of our reaction? Carbon dioxide. Carbon dioxide was being let loose. So carbonated water or carbonated sodas or whatever is just the addition of carbon dioxide. So I could have technically collected all of that carbon dioxide and I collected that liquid and I could put it all back. It would be exactly the same, except it would have the minty flavor. But if I was smart enough, I could separate that minty flavor, right? And still end up with the same soda that I started out with. So if I could do that, that would make it a physical reaction or a chemical reaction.
Oh, yes.
That's right. That would make it a physical reaction. What you guys did was a physical reaction because all you did was release gas and a little bit of soda. If we were smart enough, we could collect all of that soda and that gas that we released. And then we could separate the Mentos and the mint flavor by using aspects of characteristics of each of those things. Okay? So in theory, I can get everything back without making a single chemical change. There was no chemical change that happened in that reaction. It was all a physical reaction. So in the case of a chemical reaction, that means what then, if that was a physical reaction? It's uncontrollable? It's sort of, yeah. So I guess sort of, yes. What was that? You won't be able to get back what you started with, more specific. Okay? So we're not able to get back the chemicals that we started out with. We're getting back something else. Can you guys give me an example? Think of something. What was that? Sugar and water. I can get back sugar and water, right? Because if I put sugar and water together, mix it all together, and I boil it, but if I boil it right, I can recover all the sugar, as long as I don't cook it too high, right? Because otherwise I make syrup, and then I'll make caramel, and so, if I don't cook it too high, I can get back the sugar, and then I can make water steam, and so I can end up back with sugar and water.
Put it like a lighter view.
What was that?
A lighter.
A lighter, okay? Can I get back the gas that I burnt off? Once it's gone, it's gone. Okay, so a chemical change, if I have just sugar and I cook it, and this has happened, believe me, I've done this experiment at home, right? I was making caramels and making those good caramels one time. And when I was making those good caramels, I was sat around and I was, playing PlayStation. And then I totally forgot that I was making good caramels, right? And then next thing I know, this thing is burning. I'm like, it's burning something, right? So my caramel went from caramel to charcoal, to exactly carbon, right? So, and that's exactly what we happens here. So sucrose changes to carbon and water. So that's the product. Okay, so this is called burned to a crisp, right? In the case when you're getting back just carbon and water, that means you got beyond CO2, you're just getting back carbon and water. Okay, now this is an example of a chemical reaction because I can't get back sucrose. No matter what I do, I can't get it back. Because I burnt it to a crisp. Now I have just carbon and water. Okay, so this also allows us to balance a chemical equation. Okay, so I'm going to do it on the sideboard here. And then I think we're going to stop at this point because we have 3 minutes before I have to let you go, right? So, sucrose. Its chemical formula is C12 H22 O11. The products were, what were the products? Remember? C for carbon, H for hydrogen, but was it carbon and water? So what is the chemical formula for water? H2O. Okay,
So this is called my, you guys remember? Talk about this? So this side is called what? My reactant. And this side is called my product. This here is that arrow. What does that mean? What is that? What did I call it? Starts with Y.
This is your heel or
My yield, yes. Not my yeast, this is my yield, okay? Because I yield that, right? I make it, right? Okay, so we know that this represents how many carbons that we have in this compound? How many carbons are in sucrose?
12.
How many hydrogens are in it? How many oxygens? Okay, so I have 12, I have 22 hydrogens, and you said I had 11 oxygens. Over here, how many carbons do I have? 1, right? If there's no number there, it's understood to be a 1. Okay, although my 1 looks like a T. Okay, now 2,
yes.
Thank you.
Yes.
I appreciate that.
okay, and then my oxygen.
1.
Okay, so now the question is it a balanced chemical equation?
No.
What we put in, we have to get out, right? Okay, so I have, how can I make this work?
Put a 12 before the C.
Put a 12 for the C. Okay, so then that gives me 12 carbons. Okay, are we done?
No.
Nope.
No. Okay, so then
Put 11 before H2O.
11. Okay, so then that's 22 and 11. Oh my gosh. Is it balanced?
Yes.
We're done. I'll see you guys next Monday.